GLI, over. Apollo 11, thank you.
Yes, welcome to our Webinar-7. My name is Hakan Çelik. So we will be together with two distinguished panelists, speakers in this webinar. I would like to introduce them. Mr. Mesut Çiçeker, he is Vice President of Lockheed Martin, one of the most important global companies of defense and space industry. And Mr. Mesut Gökten is also with us, together with us. He's Acting Director TÜBİTAK Uzay. Welcome to our panel. Can you hear me, both of you? I think
Thank
Mr.
you.
Mesut is with us at the moment.
Yes, I can hear you clearly.
Thank you so much. Mr. Mesut Çiçeker, are you also at the moment with us, together with us? I think he will be with us soon. I would like to summarize the previous webinar. So we mostly talked about TürkSat and TürkSat technologies. With TürkSat 5A, a new era in the space begins. TürkSat 5A will be the new generation of communication satellite of Turkey and will provide broadcast and an improvement of broadband and data services. According to the plan, it will be launched into the space from the United States in 2020, as previous speakers mentioned. The signature ceremony of the production agreement for TürkSat 5A between Airbus and SpaceX was held at the third Global Satellite Show. The Global Satellite and Space Show, which was the scene of this historical signature, will present the latest news about TürkSat 5A and its opportunities this year. So we already talked and mentioned about technologies and development of different technologies and engineering areas. I wonder, does Mesut Çiçeker join us? I think he will be here soon. In this webinar, our subject is Best Discipline to Manufacture a Satellite. Despite the high cost of manufacturing and launching a satellite, countries and companies invest in a satellite manufacturing more than ever to provide more accurate data for their technology. There are especially low orbit satellites, which are the most demanded by technology companies nowadays. So those satellites can offer high-speed internet connectivity, which is very important, highly precise navigation and cloud computing capabilities. Those capabilities are very important for customers and companies and institutions, also for defense purposes. The pioneer satellite manufacturers will come together and share their ideas about the best satellite manufacturing discipline. Also, this, I think, webinars will be very useful to understand this technologies. I think he's not together with us. Mr. Mesut Çiçeker will join soon. Let's start with Mr. Mesut Gökten. He's acting director. Yeah, he arrived. Welcome to our webinar, Mr. Mesut Çiçeker. It's very nice to see you. You were in Turkey previously, as far as I know, and you are in Brussels, or
Thank you.
let's say,
Likewise. Thank you.
you are in Belgium, right? Can you hear me, Mr. Çiçeker? Can you hear me?
Yes, I'm in Belgium. I think we have some delay somehow that I see on the video.
Okay, but you
Yes,
can't hear me.
I do hear you. Yes.
All right. I think our friends in technical area
And my
will check
microphone is open.
what is the
It's
reason
on.
of this delay or echo. Maybe some of us has to decrease the volume. In my opinion, I'm not the expert about this, but I think my friends will write me, and then I'll let you know. So I would like to start.
Yes, I hear you.
Okay, so then it's okay. So, Mr. Çiçeker, you have an enormous experience in this business, satellites, and also defense technologies. I mean,
Yes,
in
I
the
hear you.
Okay, let me ask my colleagues. I wonder what is the technical issue, what is the technical problem, because I think there is a little delay that Mr. Çiçeker are not able to.
Yes, I think we have a delay, and I am having difficulty to hear you now.
I think they will solve soon. Let me start with Mr. Gökten. I would like to start with Mr. Mesut Gökten. Then I'm sure our friends will solve the problem soon, and I'll come back to you, Mr. Çiçeker. Mr. Gökten, welcome to our webinar again.
Thanks a lot.
Yes, I would like to listen your opening remarks or first comments. Then I have some questions for you, and then for Mr. Çiçeker as well. And if you have a presentation, we are also ready to listen or watch.
Yes, actually, I have a presentation. Maybe I can share it first.
Thank you.
Okay, I'll accept that. I think I'm sharing my screen right now.
Yes, correct. We see it clearly. Thank you.
Yeah, everything is okay, I guess.
Yes.
Okay. My name is Mesut Gökten. I'm director of TÜBİTAK Uzay. And first, I'd like to talk a little bit about our institute, and then I'll talk about the new space concepts and the best discipline to manufacture a satellite. So, TÜBİTAK Space was founded in 1985 as Ankara Electronics R&D Institute. We were mostly focused on information technologies at that time. Our satellite activities started in 2001 with the BILSAT satellite. And the BILSAT satellite was actually a technology transfer program. The aim was to gain know-how in this field. And it was launched in 2003. And in 2006, our institute was renamed or rebranded as TÜBİTAK Uzay, Uzay meaning space. So from 2006, our main focus is space. We launched our first national satellite, RASAT, in 2011. Actually, it was the first national observation satellite. it was an R&D project and it had no customer. We are still operating Rasat at this day. At the same time, we were actually developing Göktürk 2 satellite. It's again an Earth observation satellite that was launched in 2012, and it was our first satellite that was actually built for a customer, for an end user. And in 2014, we started the TürkSat 6A project. It's the first national communication satellite. It's a geo satellite. We are still working hard on that project at the moment. And in 2017, also we started Image satellite project. It is an Earth observation satellite again, and it's the first sub-meter resolution Earth observation satellite that we are developing. So as you see, every satellite we build is a first for us. So we are always excited about our projects. So what we did actually in these projects, as I said, BuildSat was a technology transfer project, but even though it was designed that way, we actually put 2 of our equipments on board the satellite. And also Rasat had 2 indigenous developed equipments, which was launched in 2011. For Göktürk 2, we put 5 new equipments on board the satellite. And as you see, we are always trying to increase the local contribution in our satellites. We want to put more and more equipments that we develop. And as I said, we are currently working on Image and TürkSat 6A projects. They will be launched in 2021 and 2022, hopefully. And, excuse me. In these projects, we are also developing more and more equipments in Image project. The star is the high-resolution camera that we are developing in-house. And we are also developing most of the equipments, AOCS equipments in this case, for Image project. Similarly, for TürkSat CA, we are developing most of the equipments. We even have an electrical propulsion system and also satellite management unit. So, what are the main segments of the space industry? I'd like to talk first. Ground equipments, actually, in terms of revenue, ground equipment is number 1, I think with more than 50% of the revenue. Second place is the manufacturing segment, satellite manufacturing segment. I think it's about 30% something. It changes all the time, but and the last one is, even though it's very popular nowadays, is the launch segment with about 10 to 15% of revenue. And so satellite sector is not, by industry I mean mostly manufacturing side, but also there is a service side and supply space value chain that we need to mention. By upstream we mean mostly satellite manufacturing and launch services. On the middle of upstream and downstream applications, there are satellite operators, service operators like TürkSat and SES, Eutelsat, etc. They are major contributor to the industry, to the sector. And there are also very big downstream applications like communication service providers are using satellite services. Broadcast service providers are broadly using, mainly using satellite broadcasting. There are many small companies doing Earth observation, value-added services, and etc. So, space sector is cross-cutting many other industries at the moment. So, when we talk about new space, we have to mention about small satellites. We have to talk about small satellites. I'd like to talk about the small satellite classification. Femto satellites are from 10 grams to 100 grams. Actually, I have never seen one. They are very small to be useful. They are usually experimental satellites. So pico and nano satellites, they are very popular for the last decade, I guess. They are mostly CubeSats, and again, they are mostly experimental or educational satellites. And we have microsatellites from 10 to 100 kilograms and mini satellites which have the range from 100 to 500 kilograms. This is where satellites are actually getting very useful commercially. So when we talk about small satellites taking over, it's mostly about micro and mini satellites. And traditional satellites are mostly larger than, heavier than 500 kilograms. So this is not a very recent data, but it shows that small satellites are launching more and more, gaining more popularity, and especially nanosatellites. But there will be many more micro and mini satellites to be launched in the next decade. We expect something around 10,000 satellites, micro or mini satellites, to be launched in the next decade. So they will be the main value creator in the space business. So I'd like to talk about the evolution of satellite manufacture and what news is all about. In the past, satellites were usually large, and now they are getting smaller and smaller. In terms of operation, they were centric. They were mostly government or large entities were using them. Now they are getting distributed, so you can access these satellites all by yourself. You can directly images from an Earth observation satellite. You can send commands to a satellite, etc. So it's changing. And satellites were expensive. They were big and expensive, and now low cost is the focus in the future. There were year-long programs, 5 years, 10 years were regular times for satellites. Developing a satellite platform took something around 10 years, but now we're looking for short time to orbit. The responsive space is the new trend now. Launch vehicles were single use, and they were also expensive, obviously. Now we are seeing more and more reusable launch vehicles. And satellites are were one of actually. There were only single satellite missions, like communication satellites or Earth observation satellites. They were acting on their own. But nowadays, satellites are working like teams. They are in constellations. They work together. They communicate with each other. They form a network with each other. And in terms of customers, in the past, mostly it was driven by public sector, military, government, or scientific entities, space agencies. Now and in the future, mostly the customers are private. And if we compare the companies, in the past we had very big giant companies, and now we see more and more startups taking the share. So what's the new space approach? The main focus, one of the main focuses is the low cost, and we try to reduce cost by doing more R&D in the development phase, and we are focusing on incremental development. In the past, we would develop a satellite completely qualified on the ground, send it to space, and never change anything. But now since we are developing small satellites and constellations, with every launch we can make some developments. Again, it's mostly consumer market driven, and there is also focus on operations. There is innovation in both products, processes, services, and applications, and there are also small dimensions. Both the satellites and corporations are small. Some of companies like SpaceX being the exception. So what are the challenges of this new era? One of them is spectrum access. So spectrum is a limited source. More and more satellites are using this spectrum. Actually, tens of thousands of satellites are planned to be launched in the next decade. So spectrum access and spectrum availability is a problem. Another problem is funding. So most of these technologies are unproven at the moment. even technically things can go well. Suddenly you may have some funding issues, and also some government agencies are hesitant to invest in this business. And there is also another issue is fierce global competition. So some big companies are building some very large constellations at the moment. When they are actually active, they can dominate every other small entities or other countries. And another issue is orbital debris. As most of you know, when you launch a satellite to space, they mostly stay there for eternity. Some of them may return to Earth in 50 years or 100 years. So when there are more and more satellites are launched, there will be more debris when they are not operational, and then there may be some collisions in space. So what's our approach to the new space? There's an historical inspiration, which Ford Model T. So it was when mass production began. So production was flexible. It was dependent on standards. It was actually looking for global markets, and it was staff friendly. So currently in space industry, we don't have we have very limited production, and we are looking for mass production models. So with mass production, there will be economies of scale involved. And another important factor is that we want to use more and more commercial components, and we want to qualify as commercial components and then actually use them in space. We want to automate our test procedures. It's very labor intensive at the moment. We'd like to, we're actually working on new manufacturing techniques like additive manufacturing that can reduce the cost or also reduce the schedules. And automated manufacturing, automated AIT, we are not there yet, but in the future, maybe if we have more volume, that we can work on those. So what are the methodologies that we'd like to work on? One of them is concurrent engineering and lean engineering. So there's satellites are also called paper sets. So there's lots of paperwork required in satellite business. Actually, we would like to reduce this burden on us. So we'd like an early incorporation of all engineering disciplines. That's not something we are very successful at the moment. And in space industry, there are very structured reviews like PDRs, CDRs, LRRs, etc. We'd like to reduce those reviews, and we are more focused on peer reviews. And also in the past, we were mostly focused on technology innovation. We were trying to make things smaller, faster, cheaper, etc. But now we'd like to work on process innovation. So we have to, especially in our design and manufacturers phases, we have to be more innovative and more faster. So another methodology is functional and environmental testing. In order to establish a product baseline, which in turn will facilitate the serial production of a satellite, we need a thorough qualification of the new design, and it's crucial. But also, when you are developing, when you're in a mass production, and you are doing design increments in each phase, delta qualification of design increments are also crucial. Baseline design. So once the qualification of a satellite is completed, then the satellite design must be baselined or freezed in simple terms to establish a common ground for an exclusive configuration management. Design changes must be exclusively managed and should be justified in terms of customer needs and their impact on manufacturing standardization. And this is also important. We were not focusing on the manufacturing aspect and the impact of design changes on manufacturing. And we're actually focusing on this area. And also we have to closely look the obsolescence of components. And after all these phases, it's time to enjoy a scale of economy that we create. Implementing a freeze product baseline will bring minimized cost and less market. Furthermore, to make use of the manufacturing learning curve, a set of shop floor best practices should be developed, like lean manufacturing, etc. And I think that's all for now. Thank you for listening.
Thank you very much, Mr. Mesut Gökmen. TÜBİTAK is one of Turkey's most respected institutions and very important scientific research center. And I carefully listened to your presentation. And I didn't know that there are satellites even smaller than pico level. So a gram scale. I didn't know this. It is a new information for me. So thank you very much. And I am sure Mr. Mesut Çiçeker has lots of information, and I'm sure he can speak hours and hours with enormous 43 years knowledge and experience. Mr. Gökten, thank you. And Mr. Çiçeker, welcome back. Can you hear me now in a better way?
Thank you. How about yourself? Do you hear me?
Thank you. Thank you very much. Yes, I can clearly see you and hear you. Thank you. It's all perfect. So I would like to listen your opening remarks and first comments. Then I have questions for you and for Mr. Gökten as well.
Thank you. I think our Lockheed Martin fire system was causing some difficulties. And after I just received the message on my screen, I kind of get out of the Lockheed Martin network, and now we are able to communicate. And I'm very sorry that I missed almost a big part of the presentation made by my dear colleague from Mr. Mesut Gökten. Um, well, thank you very much for inviting me to this webinar. Uh, I'd like to contribute to some of the things that I've seen over 40 years of my aerospace life, I can say, which started out of a very, as a coincidence that I became a space engineer by coincidence. I graduated from Istanbul Technical University and went to Canada. Was looking for a job, and I think my luck that I was introduced to a technician who was working in a space company providing transponder subsystems to larger aerospace companies, and it was in Montreal. It's called in those days Spar Aerospace. Well, uh, I think space industry made great advancements over the years. It all started with space race between Russia and U.S. Uh, mid 20th century, and uh, thanks to those first military or government programs which brought us to this point today. It all started with uh, defense or space race, access to space, and then it was really commercialized over the years. Um, I think space is still suggesting a lot of advancement, a lot of opportunities. Uh, beside the communications and very fashionable these days broadband applications, I think uh, space exploration also will give us wonderful opportunities. Uh, I mean, going to the moon and then asteroids for some mining, which very valuable mining opportunities, and then going to Mars. Uh, I may not see this in my lifetime, maybe going to Mars, but I think sometime in mid 30s, uh, this is going to happen. And I'm also very proud that my company is involved uh, with Orion project, which is the prime contractor for Orion project, which is the deep space exploration vehicle, which is going to get us to moon, asteroids, and then Mars finally. I think what I'm trying to say is, first, space is started with a space race between two big nations, and then a lot of military applications, and also the commercial space took the advantage and got the benefits of the all the applications done for the institutional and government programs. And but the first tryout in 60s and 70s were for defense programs in US. Then it was certified for commercial applications. I think I'd like to finish this part is saying that space is offering and will offer a lot of opportunities. And I'm very happy that uh, Turkey also is taking its role in this space race. It's in the we call Space Club. Turkey is part of the Space Club because of its uh, space involvement going back to late 80s and 90s.
Yes, thank you very much indeed for your comments. And as you mentioned, yes, Turkey is trying to access and join this club, Space Club, which is very important. And in the previous presentation, Mr. Mesut Gökten also mentioned about some developments on these technologies and process. Mr. Gökten, I have a question for you. You told us about the new space trends. Can you tell us how and why did this trends emerged? I think we have a difficulty to hear. Can you please switch on the microphone? Yes, now it's okay now.
I think you can. Sorry about that.
No
So
problem, please.
so things changed when people when the way people think about space has changed. Previously, mostly about it was space was mostly about public sector, government agencies, militaries, and scientific communities. So they were mostly focused on reliability, dependability of space, and not cost. But after commercial entities were involved in space more and more, and as you know, commercial entities are mostly focused on revenues, margins, and cost. So now the main focus of the new space is reduced cost and accessing more people, increasing revenue, etc. And another factor is the cost of launch vehicles. Now, since we are reusing vehicles again and again, the cost have reduced dramatically, and we expect the cost will be reduced even more in the coming decades. So there is so you can build low cost and low reliability satellites and launch them and then you can, if it fails, you can then try another one that can work actually. So and also on the consumer side, there are changes. In the past, for example, for video access, people were mostly interested in broadcast, TV broadcast, but now consumers are interested in streaming. They like to watch whatever they want, whenever they want. So it also changed the satellite industry also.
Yes. Thank you for the answer. And I would like to ask a question for Mr. Mesut Çeker. I want to continue from your last comments, your last words about Turkey's ambition to join to Space Club. What are your thoughts for Turkey in space? And can you please add some more information or opinion on this subject?
Sure. Am I still coming clearly?
Yes, very clear.
Okay. Well, I go back in mid 80s or late 80s. The uh, previous president of Turkey, Mr. Turgut Özal, wanted to have some satellites for Turkey. And at that time, PTT organization in like, I think it was 86, 87, that they started checking out, what can be done and how they can procure a satellite. And uh, early 90s, I think it was 91, if I'm not mistaken, uh, Turkey signed a contract with Aerospatiale to provide, to procure actually two satellites with one option. And here I'd like to also compliment to Dr. Aygün, who's now the CEO of Monacosat, and he was in charge of the space section of the PTT, and he was running the Gölbaşı station at the time, uh, taking signals from different satellites, which they can be able to see from that position from Ankara Gölbaşı. And uh, the first satellite, unfortunately, had a launch mishap, launch failure. Uh, it was, I believe, 94 January, and then, uh, but it was very wise that the contract was put together for two firm and one option. So they used the option, and also they updated the market requirements and coverage areas. And Turksat 1B finally was launched in 94 August. Uh, I remember in those days, uh, in the media, I don't remember who was the editor, was saying, why we call this satellites Turksat. Turks did not do anything. Uh, Turks did not put even one screw on the satellite. I think it was a very short-sighted view. Uh, Not every country makes the satellites. I mean, but buying satellites, you start this journey. And Turkey started its journey in late 80s by launching two satellites in 94 and 96, Turksat 1B and 1C. Turkey uh, became a regional important satellite operator, covering covering from England to almost China because of its orbital position. Uh, and see today where we are. Today, the Turkish aerospace industries, TAI, has a wonderful and state-of-the-art facility, and they can build, which they are building, from small to almost 5 metric ton satellites. The infrastructure is there. So if Turkey didn't start this journey at that time, buying some satellites and taking its position in the space club and training its engineers, uh, and also encouraging youngsters to go into this field. Uh, in my time, in 60s or 70s, Turkey didn't think those things, but thanks to some visionaries in Turkey that they wanted to do this, and today is also, I imagine, TÜBİTAK also is involved very heavily for designing and manufacturing satellites together with TAI, Turkish Aerospace Industries. So the way I see, uh, first of all, we receive good uh, university education, good technical. We have good engineers. All they need is experiments, experiences, and chances. I mean, uh, this is in our genes, actually. Also, I am a graduate of Istanbul Technical University, and I didn't know anything about space, but the education I received uh, and my ethics, the way I work, uh, I took those chances well. I think the Turkish engineers, if they are given good chances, they will do wonderful things. Uh, so I think everything, it started with Turksat uh, first generation program. Today, Turksat is about to launch its fifth generation satellite and operate it. So a lot of experiences over the 3 decades. And now TÜBİTAK is involved. uh, Thai, Turkish Aerospace Industries, they have the facilities. Now it is the time to not only manufacture what Turkey needs, but also to go into a partnership and collaboration with some of the industry giants to do bigger things, to provide systems for the third countries. And this is the way to sustain for the infrastructure. Making satellites for only Turkey needs will not be sufficient. So Turkey, after gaining momentum in making its own systems, it has to provide subsystems and systems to other nations, other aerospace. That's how I see. And also, Turkish Space Agency should involve with European Space Agency, other national agencies, and NASA. It should take also part in the space exploration. Uh, there is certain level of infrastructure which allows uh, for manufacturing and providing uh, hardware or software or design engineering. Turkey, I see a lot of good initiatives to come in future. And hopefully they will come to fruition, and Turkey will become a good space nation. It is
Thank you.
already, but it can grow more.
Thank you very much. Very important points you mentioned. Uh, I want to come back to Mr. Gökten, Mesut Gökten. My previous question is about it was the space trends, and you mentioned about this subject. How will this trend change our daily lives? Can you also explain for among our audience there are new beginners on these subjects?
Of course. Now, space was part of our lives back then, even in 60s, I guess. So first live Olympic Games, I think it was an Olympic game that was transmitted through a satellite. And in the lives of civilians, it was mostly limited to that, actually. For the first 2 or 3 decades, it was mostly TV broadcasting. And then later on, the other applications we started to see in our lives, like some communication applications, etc., and also GNSS applications that we started to use in the, I think in the beginning of 2000s. But now space will be more and more in our lives. Actually, one change is if you look at the sky in the next few days, few years, you will see actual trains of satellites. That's a change for us. It's very exciting actually, and you will have more connection. You will have broadband connection wherever you go in the world. So even though we think we have connection everywhere, but when you go off-road somewhere, where you go rural areas, or when you go third world countries, you don't have any broadband connection, and that's a big issue. So when you go those places, wherever you go in the world, even in Antarctica, you will have good internet coverage. You will be connected, and also our lives will change in some other industries that we know that we will not be aware they are related to space. Space is now being used in agriculture, and it's used in insurance business. It's used in transportation agencies. So space is cross-cutting more and more industries every day. That even though we're not aware, space is being used here and there. Actually, it's being used everywhere. I think it will change our lives. It will be cheaper and more accessible. I think that's an exciting time, and a big revolution is coming.
Yes, there is a high demand for high technology among ordinary customers. So it means there will be another race for reaching high technologies and components on space competition. Another question for Mr. Mesut Çiçeker about we were talking about big and small satellites today in previous webinars as well. What are the key differences for manufacturing small and big satellites, Mr. Çiçeker?
Well, I think Mr. Gökten also indicated and classified the size of the satellites. I think the big difference, in my opinion, is in the design and approach of how to manufacture those. The assembly and integration approach is the big difference, in my opinion, beside the sizes. Now, as Mr. Gökten indicated, uh, a- those mini satellites, nano satellites, and small satellites are the objective is uh, to be very cost effective, very short schedule. Uh, Depends on the quantity, the volume. So, like hundreds, for example, Starlink, already 600 plus small satellites are orbiting around the globe, and OneWeb, although it had some financial difficulties and it's in kind of they filed the Chapter 11, but I'm sure some other investors will do the necessary to realize this project. And Telesat is planning to launch almost 1,000 plus satellites. Now, also, Mr. Bezos is planning Amazon constellation. Those are like based on low cost, high volume, uh, and they're very stringent about the integration and test approach. Uh, After qualifying the qualification unit, uh, the amount of testing on the follow-on spacecraft is minimized. That that results with the uh, huge cost savings and very short schedules. How they do this? Because if they lose that mission, the replacement is easy by launching many of those. Like uh, I think August 18, the last batch of Starlink satellites were 60 or 70 plus satellites were injected into orbit. Uh, when it comes to large satellite, uh, usually there are not many. Like you don't manufacture 5+ ton satellites in huge quantities. Like look, the Turksat 5th generation. I think 5A and 5B, two large satellites orders. Why? Because it is expensive. It takes a long time to manufacture and get ready for the launch. Launch price is higher. You pay today. SpaceX price is we're talking 75 to 80 million dollars, or sometime 90 million dollars for one shot. So a lot of at stake, and uh, for a large 5+ metric ton with 60, 70 plus satellites with spot beams, steering antennas. Uh, a single launch, if you think about all that, you're close to 300, 400, 500 million dollar of a price tag to have that satellite launched and ready for the operations. Uh, so you test, you make sure that the system will work, not like those small satellites. If it doesn't work, you can replace it because it didn't cost you much time, it didn't cost you too much money. Um, so that is the big approach difference, in my opinion. The financial metric, time metric, uh, and basically the cost. Uh, to say that also, sometimes a small platform also can cost you a lot. What is that? When you send a platform to explore space, which is sending something to Mars, it is also size-wise, it could be small, but again, it's a very time-consuming and one of a kind. You don't make two, you don't make three, you make one. It takes long time to put together those type of missions, and it costs a lot of money. So we have to distinct what is the mission. If the mission is low Earth orbit constellation with hundreds of satellites, yes, uh, you can afford cutting the corners and making like a cookie cutter type of approach to integration and test manufacturing. But if it's a one of a kind or very expensive platform, then it takes today 36 to 48 months to manufacture those satellites, and they are so a lot of stake, a lot of at stake for a large platform, and that's why the approach to integration and test and manufacturing, it's a huge difference. Um, and also, uh, there's a reliability issue. Like today, the large satellites, like Turksat 5A, Turksat 5B, or fourth generation satellites, uh, they serve 15, maybe 15 plus years of services. And the reliability factor is very high. Almost you want to reach to 99.5, 99.9% reliability for mission success. Uh, uh, right now, we don't see that reliability element that high because those are still in the infancy period of those small satellite constellations, and uh, some of them are in financial troubles, like OneWeb. Out of the let's say middle MEO, like medium Earth orbit missions, uh, O3B is one of the most successful of the projects. All the others had financial difficulties. Maybe we can include also Iridium Next follow-on Iridium program. So um, as much as I am excited to see the small satellites, constellations, and MEO applications, uh, I want them to be very successful, but also they have to prove their reliability and financial health. Uh, the time will tell us. One important thing to also to pay attention, Mr. Chelik, is uh, we have to do this. Uh, we human beings, we consumed Earth. Today, we are trying to protect and save Earth, we have to be careful not to do the same to space. However, all the signals that we see today, we hear, we experience, we have lots of space junk, especially in the low Earth orbit. There are more than 10,000 space objects sizing 1 to 10 inches circulating with a very high speed in the low Earth orbit. Today, I would be also extra cautious if I was uh, promoting a small satellite constellation in the low Earth orbit. I would be also very concerned about the accident probability. Uh, every day almost we hear small satellite applications and constellations filing, and they are injecting those satellites into orbit. Uh, we also have to clean uh, Earth low Earth orbit from this unused objects. That is also open another business opportunity for some companies, but it's a big concern at this point.
Yes, very important point. You're warning about consuming Earth and additionally space as well. Is there
Yes.
a technology at the moment to cleaning up this orbit level junks? Do we have?
Yes, yes. Right now, it's in the design phase, but uh, I mean, big primes like Lockheed Martin, Airbus, Thales, uh, uh, Northrop Grumman, and Boeing. They have different designs and projects, and also there is also big financial backing for those projects. We will see those like almost like uh, a space vehicle, let's say a type of spacecraft going and taking those objects uh, and getting away from low Earth orbit. Uh, so that there are a number of initiatives we don't have today, as of today. Uh, Actually, it didn't start, but it will. We have to.
I hope they will not also pick up useful satellites as well,
No,
because
uh,
we need them.
no. Sure, the technology will not make us those mistakes.
Of course, they will select the correct satellites. So the final question, the final subject: how will TÜBİTAK Space involve in new space? Are you taking any actions?
Actually, last couple of years we were very busy with two big satellite projects that we were working on, Imece and Turksat 6A. So we were not very active in this space, in the new space actually. But since we are now getting into the AIT phase of these satellites, now we are looking for new projects, new opportunities. And one of the opportunities is, I guess, small satellites and new space. And this year we started working on new projects, new approaches, but we have to change the mind of people, I guess. First, people are used to work in satellite business is more focused on reliability, and they're very much focused on reliability. They don't get the idea of building a satellite with low reliability. It's horrendous to think that they manufacture a satellite and then it will fail. So we have to just first accept the fact that it's an option now. Failure is an option in new space. And we're actually in business development phase in a couple of projects. We are working on the concepts. We are looking at how we can improve our manufacturing facility, how we can adapt the facility. We were actually today discussing how many satellites we can manufacture in our current facility if we can make some changes. And we're also working on some payloads for small satellites at the moment. So
Yes.
next year we hope to find a new, we have to sign a new contract, hopefully, and start with some bold actions.
Thank you very much. So this is the final of our webinar. It's a great benefit to listen and share your opinions and your valuable information. Thank you for both of our distinguished panelists, Mr. Mesut Çiçeker. He joined us from Belgium. He's the Vice President of Lockheed Martin. And Mr. Mesut Gökten, Acting Director of TÜBİTAK Uzay. He joined us from Ankara. And I also would like to thank the audience for watching us. Good evening. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Good evening.
Bye-bye.
Bye.
Apollo 11 Houston, you're good in 1 minute. Apollo 11, this is Houston. You are go for TLI, over. Apollo 11, thank you.